Hello everybody, we are dealing with an interesting problem based on the concept of electrostatics. So we will be applying a lot of concept in this problem, and this problem is from the book Science for Everyone by S.S. Krotov. Let's get started with the problem. Two small balls of mass m bearing a charge q each are connected by a non-conducting thread of length 2l. At a certain instant, the middle of the thread starts moving at a constant velocity v perpendicular to the direction of the thread at the initial instant. Determine the minimum distance between the balls. So if you want to give this problem a try, pause the video and attempt it, or otherwise continue watching. So let's get started with the problem. So the first thing that we are going to do is we are drawing a diagrammatic situation. So this is how we can understand this situation. So over here, these are the two charge balls which the problem is referring to, each having a charge q, and they are separated by a distance 2l. So the two charges are separated by a distance 2l. Perpendicular to this, a velocity v is imparted, as a result of which the system will start moving in the upward direction, that is, the string will be moving in the upward direction, and after a while, if it is having a velocity v, then due to the force of interaction between the two charges will start moving towards each other. So we can say that if it is having a velocity x in this direction, a velocity x will also be in this direction, such that we can say that initial momentum in the x direction is equal to the final momentum in the x direction, because there is no external force in the x direction. So we can say that the momentum in the x direction is conserved. So at a point of minimum separation, at a point when minimum separation is attained, so at a point of minimum separation, the velocity Vx will approach 0. So at the point of minimum separation, this velocity Vx which we are referring to will become equal to 0. So they are approaching each other because of the tensile force which is developed in this thread, and at the same time they are repelling each other because of the electrostatic force which is in this direction, by virtue of which the two equal charges are repelling each other. So if we are solving this problem, so we are applying work energy theorem to solve this problem, because it will be convenient to solve the problem this way. So initially at this instant, if we write initial energy associated with this situation, so we say total energy which we write initially. So initially the total energy is in the form of electrostatic potential energy. So we write it as K Q1 Q2 by separation between the two charges, which is equal to 2L, and followed by this we will write kinetic energy. So kinetic energy of each ball is half mv square. So initially when we give it a push v, so when the block start rising, the two of the balls will be having a velocity v in the upper direction, and then gradually after a while they will start moving towards each other when other forces will come into act. So initially at t equal to 0, when this pull is generated, the velocity is in the upper direction, so it is having velocity half mv square, and we are multiplying it by 2 because both the balls are having the same velocity. So they are having total kinetic energy half mv square times 2. So now in the final condition, so if we write the final energy associated with this configuration, so we say at the minimum distance point the velocities in this direction will be 0, and at this point if we are writing this, so we are writing it as K Q1 Q2, and the distance between them will be written as d. So at the moment of the closest approach, the energy of the system will only be written as kq square by d, and it is very interesting for us to understand that when we are solving this problem, we are selecting an inertial frame which is moving with the center of the thread with which we are solving this problem. So this is the point of reference about which we are trying to solve the problem. So the final energy is written as kq square by d. Now if we equate the two energies, that is initial energy is equal to final energy, so total energy initially must be equal to total energy finally. And if we write this expression, so kq square by 2l plus mv square is equal to kq square by d, and we are referring this d as d minimum, that is the distance of closest approach, and we are looking to solve for this d minimum, and on solving we can write it as that d minimum. So we are solving it in this way, that 1 by d minimum so we can write this as q square upon 4 pi epsilon naught, so it will become 8 pi epsilon naught times L plus mv square is equal to q square upon 4 pi epsilon naught d minimum. And then we can rewrite this as q square plus 8 pi epsilon naught mv square L by 8 pi epsilon naught L is equal to q square upon 4 pi epsilon naught d minimum. So if we solve this part, so from here we can write d minimum as 2l q square divided by q square plus 8 pi epsilon naught mv square L. So this is the final answer for this particular problem, so which we have solved. This is the final answer which we have. So I am again letting you go through the entire problem. So this is the problem which we had, where two identically charged balls having charge plus q and plus q are given a pull initially in this direction. The thread is non-conducting in nature, so as it will be moving in this direction, the two balls will start approaching each other, but at the same time a repulsion force will act so as to keep the balls away from each other. At the point of minimum separation, we say that the velocity along x direction will become 0, and this is the point where the two balls will be attaining a position where the separation between them is minimum. So we are solving the problem from the inertial reference frame fixed to the moving center of the thread. So this is the point about which we are solving this entire problem, and about this point, if we are stating the total initial energy, so initial energy of the system is equated with the final energy to get the final answer for this particular problem. So this is the necessary calculation which we have done to obtain d minimum. So I hope you enjoyed watching this video. To enjoy more such videos or to continue problem solving with me, do like the channel. Please like, share and subscribe for more such problem solving videos.